I will show you how to trace images formed by curved mirrors. I have a circle. In essence, curved mirrors are circles. They just cut it and take the portion they want. Say, for example, here, if we cut this part and leave this part, this shall be the mirror. But first, let's identify some salient points. Of course, we know that this is the center of the circle. From that center up to this point, vertex. And here will be the center C. We already know that from the center C up to the vertex V is our radius. But in this case, I will introduce a new term. Half of the distance between C and V will be our F, or the focus or focal point. And then the distance between F and V shall now be the small f, focal lengths. And now I am ready to erase all of these. So this is our mirror. The reflecting surface is this. It's the cave part. That's why it's called the concave mirror. This is the coated part. Now let us place an object somewhere here. An arrow. An arrow is a good representation of an object because it has a head. Sometimes our image inverses. There are unlimited number of rays that we can trace from the object. Actually, just 2 rays will be enough. Just for the purpose of demonstration, I will show 3 rays. The ray parallel to the axis going to the mirror. When it hits the mirror, that ray will reflect, of course. Where? Where will it reflect the light? So this one will reflect at F there. That's our F. Let's extend it. That's the first ray. The second ray shall be coming from the object as always. We will send it to the mirror passing through the F. When it hits the mirror, will reflect parallel to the axis. The third ray shall be passing from center C. And when it strikes the mirror, it will reflect, of course, it will reflect where? It will reflect to its initial path. So the easiest ray actually is the third ray because once you make it pass through center C, it never changes direction. Alright, now the question is, where is our image? Well, our image is formed at the intersection of all reflected rays. Where is our reflected ray? Where is that point? This is our point. So it follows now that our arrowhead must be here. Therefore, my arrowhead will come from here. That's our image. An inverted one. I will now place the object between F and V. Let's start with the first ray. It goes from the object to the mirror. When it hits the mirror, what will happen? It will reflect back, passing through the focal point or focus. Next ray is again the ray coming from the object, passing through F. Let's extend that one here. Let's extend it here for it to hit the mirror. Now when it hits the mirror, it will reflect back parallel the axis. The problem here is that there is no intersection. Reflected rays did not intersect. Okay, so let's try the third ray, the one coming from the object, passing through the center C here, and we can extend that to the mirror, and again there is no intersection. Well, you might ask, is this an intersection point? Well, that is not an intersection point because the intersection we are going to consider is the intersection between reflected rays. Okay? You may see incident rays intersecting, but no. Only the reflected rays will form the image. Right? What we can do is to extend the rays. Which ray? Again, remember that we can only extend the reflected ray. We can never extend the incident ray. So where are the reflected rays? This one here, this is the reflected ray, this one. So we can extend that here. Actually, we should use a broken line because it's imaginary. It's going behind the mirror. Next, let's take a look at the other reflected ray. Of course, this ray going to C can be extended wherever we want. Even behind the mirror, we can extend it here. Alright, so that's our third ray. Now we see an intersection. Another ray that we can extend is this one. This is the incident ray. This is the reflected ray. So we can extend this. Okay, and then we see now that again we have intersection of the three lines. Only this time our image is formed behind the mirror. Okay, it's bigger now, but we should bear in mind that this must also be an imaginary line. In physics, we call this virtual image. So that's a virtual image of this real object.